Hello. Today we're going to explore how energy transfers in a system might take place by considering a few different examples. A system in physics just means an object or a collection of objects. Now, being able to identify energy transfers in a system is an incredibly useful skill, especially if you're going to be sitting an exam soon, so if you are, listen up. One of my favourite systems to consider for this is a bouncing ball. At first, it seems like it's very simple, but there's actually quite a lot of different energy transfers taking place, and being able to identify and explain these is quite straightforward and can get you a lot of marks if it comes up. So when you hold the ball up in the air at first, what type of energy is it storing? Well, it's not very hot, it's not moving yet, it's not a magnet, but it is quite high up. We're holding it up in the air, so that means it has some gravitational potential energy. Right, that's how we start. Now, when I let it go, it's going to move down. So that means the gravitational potential energy is decreasing. So where's it going? Well, the ball has started to move. So it's going into movement energy, kinetic energy. The first energy transfer that we have is going from gravitational potential into kinetic energy. As the ball falls, it gets lower and lower and faster, so more of that gravitational potential energy is going into kinetic until it hits the ground and suddenly it stops. So all of that kinetic energy is going somewhere. Where's it going? Well, as you can see here in this example, the ball squashes ever so slightly as it hits the ground. And remember, anything that's been squashed is storing elastic potential energy. So now all of the kinetic energy that it had right before it hit the ground has gone into elastic potential energy. Then it unsquashes itself and launches itself back into the air. So as it's unsquashing, that elastic potential energy is turning back into kinetic energy to make it move really, really fast. And as it moves upwards, it's going to slow down. So again, the kinetic energy is now getting less, but it's getting higher. So the kinetic energy is now turning back into gravitational potential energy. And the whole system will repeat. Gravitational, kinetic, elastic, kinetic, gravitational. Round and around and around. Nice. Let's consider one more system. What about a handheld electric fan? Well, we start off with a battery, which is a store of chemical energy. Then that energy gets transferred along an electrical pathway through the circuits inside the little fan. Once the energy reaches the motor, which is turning the blades, well, that electrical energy goes into moving those blades around, so it's going into kinetic energy. Nice. Now, in all energy transfers, there's bound to be some energy that's wasted. Very rarely do we ever get an energy transfer that is 100% efficient. We'll talk about what that means in a later video. But all you need to know right now is that some of the energy is going to get wasted somehow. So let's start off with the bouncing ball example. Well, as the ball's falling, there's going to be a bit of air resistance as the ball falls. And that's a type of friction. The air particles are actually rubbing up against the sides of the ball. And whenever you have friction, you always get heat generated, or heat transferred, I should say. So some of that energy is being wasted as thermal energy as the ball falls. And it'll be the same case for when it hits the floor. Some of that energy will go into heat in the floor. You might also get a bit of sound, depending on how loud the ball is when it hits the floor. With the electric fan, well, we've got an electrical circuit, and energy is always wasted as heat when we have an electrical circuit, even if it's only a tiny bit. That's why your phone can get hot when you're charging it. Lots of wasted energy to heat. There will also be some wasted energy as heat in the actual motor of the fan, because as the blades are turning, there's going to be little components rubbing up against each other. We've got more friction, we've got more energy lost as heat, and it might make a little bit of noise, so we'll have some sound energy wasted as well. Energy transfer questions are pretty straightforward, but you do have to think. Don't just rush in guessing the first thing that you think of. Stop, consider which type of energy you think is going to be the most important in any given situation, and then you can quite easily solve the problem. Well, that's all for now. Thanks for watching. See you next time.